In this section, we will look at various aspects in vSphere 6.5, configuring and administering vSphere 6.5 storage. In this section, we will take a look at the enhancements available in vSphere 6.5 in storage management, and there are quite a few. And then we will look at some of these essential enhancements in a lab. In this video, we will look at vSphere 6.5 storage essentials. The topics we will cover are LUN, scalability, LUN being a logical unit storage device, NFS version 4.1 support, some improvements in software iSCSI routing support, how version 6.5 of vSphere deals with advanced format drives in something called a 512 emulation mode, and something which is really interesting that's available now has been automated, which is the Unmapped API primitive. And we'll talk about these in some detail as we move along. So first up is LUN scalability. Of course, if you have smaller size LUNs, it means that the time it takes to back up and restore them is actually much less than if we had very large storage LUNs. Also, smaller size LUNs from a security perspective allow us to segregate data of a certain type or data that has certain security restrictions into manageable scenarios. So there is a possibility that the number of LUNs that would be required in a modern data center from a security perspective and from a responsiveness perspective in terms of being able to do rapid backup and restores would require a much larger number of LUNs than was currently available in version 6.0 of vSphere that came before the 6.5 version. Also, when you look at active-active clusters, having large active-active clusters eases management overhead because you have fewer clusters to manage. The more clusters you have, the more issues there are. Modern I/O infrastructures have 8 paths to a LUN, and in that case you are only allowed 128 LUNs per cluster. With the VMware 6.5, the number of LUNs has now been enhanced. You now have the ability to have 512 LUNs and 2000 paths. So to cater for the extra demand on storage that is almost a certainty with modern applications, scalability enhancements that LUN scalability provides in vSphere 6.5 are very meaningful. Moving on to NFS version 4.1 support. NFS version 4.1 is an enhanced version of the NFS that's version 3 essentially that's been in use for a long time. Key differentiators would be Kerberos authentication using the Microsoft Active Directory support that's available. In this day of secure communications, especially security while the data is in flight or is actually being stored, you need to make sure that the data is encrypted in some manner. So there are stronger cryptographic algorithms that are natively supported with NFS 4.1 with the support of Kerberos. Things like the Kerberos integrity check, sec KRB5i as I believe it's called. And then the host profile capability that's been there for a long time with vSphere environment allows us to actually specify NFS 4.1 support so that one can essentially clone hosts using the host profile and not have to add NFS 4.1 support manually as one had to do in the past. NFS 4.1 natively allows you more paths than were earlier available with regular NFS and so on. And with the newer devices, storage devices that are out there, both NFS and iSCSI are tremendously popular. So these are very key enhancements that have been waiting for a long time with vSphere, and now with vSphere 6.5 these are available. The sectors, the physical sectors on storage devices were only 512 bytes long simply because the storage didn't have the capability to do that, but now the more advanced format drives available have 4K byte sectors. So the issue really becomes how does a legacy operating system which does not support 4K byte sectors and only looks at 512 bytes or only supports 512 bytes per sector can actually utilize the more modern advanced format drives which have the 4K byte sectors, because now within a certain amount of volume you can have a tremendously large amount of data that can be stored. So if one moves to the advanced format drives, we need to be able to provide the back level support for legacy operating systems that support only the 512 byte sectors. And that support is now provided in vSphere 6.5. It's called 512 emulation, 512E mode support for VMFS and RDMS data stores. And of course, it requires VMFS version 6. The Unmap is a vSphere storage API primitive. Basically, what it does is that in thin provision drives, it reclaims dead or stranded space. Prior to vSphere 6.5, this had to be done using a command line. It wasn't difficult to do, but you could automate it obviously also, but then it had to be done from a command line perspective. What has been enhanced now with version 6.5 is that Unmap is now automated and it reclaims in the background on the storage array. This is a very important capability because when files were deleted and so on, it was kind of difficult in the early days to recover the space in a thin provision drive. And the Unmap capability has come a long way since the old days, and now being automated basically runs in the background, so one doesn't even have to think about it anymore. So having looked at some of these essentials in the storage area, some enhancements that are available in vSphere 6.5,